Hello everyone, my name is Luke Chen and I'm a PhD student in Milk Quality Improvement Program. Today I would like to show this tutorial about how to use our predictive model for milk spoilage due to spores. Before I start the actual demonstration of the app, I would like to focus on the practicality first. So the inputs for this app include microbial quality of incoming milk, which you can test from the milk in your silo. This model also needs time and temperature profiles along the supply chain, which can be recorded using temperature loggers at different stages of supply chain. What this model can predict is the percentage of spoiled milk containers at any given day of consumer storage. This app is designed for dairy processors, and dairy processors can use this app to make decisions such as what intervention strategy should be implemented to minimize the spoilage. In addition, they can answer questions, which is what shelf life date should be placed on each batch of milk containers. So why do we care about milk spoilage? And what kind of microbial quality are we talking here? So the type of milk spoilage we're interested in is the spoilage due to cycle-tolerant spore formers. Cycle-tolerant spore formers are a group of spore-forming bacteria that can grow at low temperatures, such as below 6 degrees C. These type of spore formers are ubiquitous in the farm environment, such as soil, feed, and bedding. Once they enter the raw milk, they can survive the pasteurization and outgrow in the milk once the environment becomes favorable. Their outgrowths can lead to defects such as coagulation in the fluid milk, thus making the milk undesirable for consumers. In this app, we're trying to predict the concentration of cycle-tolerant spore formers in each milk containers at the end of shelf life. We can do so by using this Monte Carlo simulation. For this simulation, we would need data such as the initial concentration of these cycle-tolerant spore formers, as well as the specific subtypes of this spore former, which will allow us to model its growth parameters. Once we have these initial parameters, we also need time and temperature distribution across different supply chain stages. In this model, we have 5 stages, including facility storage, facility to retail transportation, retail storage, retail to home transportation, as well as home storage. Once we have this data, we can use this microbial growth model to predict the outgrowth of cycle-tolerant spore formers across the supply chain. With that information, we can calculate the final concentration of spore formers in each milk containers, and then based on sporage threshold, if the concentration is exceeding this threshold, then we would consider this milk to be spoiled. Based on this simulation, we can simulate 10,000 half-gallon milk containers, and the percentage of spoiled containers can help us make decisions whether or not to implement different control strategies along the supply chain. For the next slide, I will demonstrate how we can use this app through our lab website.
Here's a short demonstration about how you can access our Milk Spoilage app. First, you can access our digital dairy web page and by typing this URL. And on this web page, you can see we have models for different dairy products. If you click fluid milk, this will lead to a page that allows you to find access to different publications we have for predicting milk spoilage. And if you scroll down, you can find the link to the model interface. Once you click the link, you will be able to enter the interface for this model. In the introduction panel, you will find out the basic information about this model, developer, funding sources, disclaimer of using this model, as well as the contact information if you ever have questions. To use this model, you can simply click the model. Here on the left panel, you will find user input, and on the right panel, you will find the simulated outcomes, which are composed of the predicted percentage of spoiled half-gallon milk containers over consumer storage up to 35 days, as well as the predicted shelf life, which I'll talk more in detail later. The type of input you can enter include the mean spore concentration in your milk source, as well as the standard deviation. These parameters are used to characterize the variation of microbial quality in your milk supply. Then you can define your spoilage threshold. In this case, we have two types of threshold. The first one is defined by the PMO limit, which is 20,000 CFU per mil. The second one is the literature threshold for detecting the sensory defects, which is set at 1 million CFU per mil. Then you can choose the percentage that will define the shelf life. So the shelf life is defined as the last day at which a certain percentage of spoiled milk containers exceeding the spoilage threshold as set earlier. And you can basically set this percentage to whatever you want based on your decision. Below that, we can set different intervention strategies. The first set of intervention strategies is to reduce bacterial load at processing level. These including microfiltration, bacterification, single pass, and double pass bacterification. Then you can select intervention strategies that can improve temperature control across the supply chain, including at facility, during facility to retail transportation, as well as retail storage. You can make your change on the left panel. For example, I can set the mean spore concentration to 1 and change the spoilage threshold to 1 million. And I want to define the shelf life as the last date at which 70% of our milk were spoiled. I may want to test out different intervention strategies and see how effective they are. In this case, I may select microfiltration, and if I do not plan to implement any temperature control strategies, I can leave them as they are. Once we click submit, the model will run for a few seconds. And you can see the updated output on the right-hand side panel. As we can see, even with the the mean spore concentration, the progression of spoilage percentage is slowed due to the implementation of microfiltration. And we can see under this scenario, the predicted shelf life is beyond 35 days. If you want to download this data to see what exact percentage of spoiled half-gallon milk containers at each storage day, you can go to Output and simply click the download button. This will lead to the download of the CSV file that you can look into in more detail.
That is all I have for this short tutorial. Lastly, I would like to acknowledge the generous funding from Allied Milk Producers, Foundation for Food and Agriculture Research, and New York State Pollution Prevention Institute. Thank you for watching.